Hello everyone and welcome to Sally and Bytes. Come on. Let's work out these NCERT problems. Flow of control part 2. Let's discuss about the programming exercises. Question 1. Write a program that takes the name and age of the user as input and displays a message whether the user is eligible to apply for a driving license or not. The eligible age is 18 years. Now, look at the Python code. Line 2. Name equals input of, enter your name. This line of code prompts the user to input their name. The input function is used to read a line of text, in this case, the user's name, from the user. The entered name is then stored in the variable named name. In line 3, age equals int of, input of enter your age. This line of code prompts the user to input their age. The input function is again used to read a line of text, which is the user's age. Since the age is a numerical value, it's important to convert the input to an integer using the int function. The converted age is then stored in the variable named age. In line 5, now, the program checks whether the entered age is greater than or equal to 18, which is the eligible age for a driving license. In line 6, if the condition age is greater than or equal to 18 is true, the program executes line 6. Line 6 uses an F string to create a formatted message. The name variable is inserted into the message using curly braces. The message informs the user that they are eligible to apply for a driving license. In line 7, if the condition age is greater than equal to 18 is false, meaning the user's age is less than 18, the program executes the line 7. Similar to the previous message in line 6, line 8 uses an F string to display a message indicating that the user is not yet eligible for a driving license. Now, look at the output. The user is prompted to enter the name. Name given Amanda, age given 24. So the message displayed is, "Hi Amanda, you are eligible to apply for a driving license." When we run the code again, the user is prompted to enter a name, Alice. Now the age entered is 12, which is less than 18. So the output displayed is, "Hi Alice, you are not eligible to apply for a driving license yet." Question 2. Write a function to print the table of a given number. The number has to be entered by the user. Now, look at the Python code. Line 2, number equals int of, input of enter the number to display its table. This line 2 prompts the user to input a number. The input function reads the input as a string. The int function is then used to convert the input string to an integer, and the result is stored in the variable number. In line 3, print of, table of, number is. This line 3 prints a message to indicate that the following lines will display the multiplication table for the entered number. The variable number contains the number entered by the user. In line 4, the for loop. For I in range of 1, 11, iterates over the numbers from 1 to 10, inclusive. Start value is 1, stop value is 11. So as it stops at 11, 11 is not included. So the value taken until 10. The loop variable I takes on values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in each iteration. In line 5, print statement is the body of the for loop. It prints a line for each iteration, showing the multiplication of number and I along with the result. Now, look at the output. This is what the printed lines look like for a sample input of number equals 5. Question 3. Write a program that prints minimum and maximum of 5 numbers entered by the user. Now, look at the Python code. In line 2 and line 3, we are initializing variables min_number and max_number to 0. These variables will be used to store the minimum and maximum values as you iterate through the numbers. In line 4, this for loop iterates 5 times, as we are using the range 0, 5 to loop through numbers 0, 1, 2, 3, and 4. In line 5, we are prompting the user to enter a number in each iteration and storing it in the variable x. Now, look at line 6 and 7. In the first iteration, when I is 0, we are setting both min_number and max_number to the value of the first entered number. This initializes both min_number and max_number to the first input value, so you have a starting point for comparison. Now, look at line 8, 9, 10, and 11. These conditional statements compare the current input x with the current values of min_number and max_number. In line 8 and 9, if x is smaller than the current min_number, you update min_number to x. In line 10 and 11, if x is larger than the current max_number, you update max_number to x. This way, we are continuously updating the min_number and max_number values as you input more numbers. Finally, you print out the minimum and maximum values that were determined through the loop and comparison process. You can check the output. The numbers given are 45, 23, 12, 78, and 98. So the minimum number is 12 and the maximum number is 98. Question 4. Write a program to check if the year entered by the user is a leap year or not. A leap year is a year with 366 days instead of 365. Every 4 years in February 1 extra day is added. This is done because 1 year doesn't contain 365 days but 365.25 days. By adding once in the 4 years 1 extra additional day, this problem is solved. Any year that is divisible by 4 is a leap year, such as 2016, 2020, 2024, 2028. Note: the above rule does not apply to century years. Centuries such as 1900 and 2000 only have a leap day if they are divisible by 400. 1900 is divisible by 4 and also by 100, but not by 400, so not a leap year. This means that centuries are only a leap year if they are divisible by 400. So 1900 is not, 2000 is, 2100, 2200, 2300 is not, but 2400 is another leap year. Now, look at the Python code. In line 2, the user is prompted to enter a 4-digit year using the input function, and the input is stored as an integer in the variable year. In line 3, the code first checks if the year is divisible by 100 using the condition year mod 100 equal to 0. Line 4, if the year is divisible by 100, the code then checks if it's divisible by 400 using the condition year mod 400 equal to 0. If both conditions are met, the year is considered a leap year. If the year is not divisible by 100, or if it is divisible by 100 but not by 400, the code checks, in line 6, if the year is divisible by 4 using the condition year mod 4 equals 0. If this condition is true, the year is considered a leap year. In line 8 and 9, if none of the conditions are met, the year is not a leap year. The appropriate message is printed based on whether the year is a leap year or not. You can check the output on the console. This code correctly handles leap year determination, and it also accounts for the special cases involving divisibility by both 100 and 400. Question 5. Write a program to generate the sequence -5, 10, -15, 20, -25 up to n, where n is an integer input by the user. Now, look at the Python code. Line 1. The user is prompted to input the value of n using the input function, and the input is stored as an integer in the variable n. In line 2, the for loop iterates from 1 to n, inclusive. In each iteration, it checks whether the current value of I is even or odd using the condition I mod 2 equal to 0. If I is even, it prints -5 multiplied by I, where I is an even number, to generate the sequence -5, -10, -15, and so on. If I is odd, it prints 5 multiplied by I, where I is an odd number, to generate the sequence 5, 10, 15, and so on. The end equals comma and space argument in the print function is used to add a comma and a space after each printed value. When you run this code, the program will prompt you to enter a value n, and it will generate and display the sequence according to the described pattern. You can check the output. The user entered the value of n as 6, so the output is 5 minus 10 15 minus 20 25 minus 30. Question 6. Write a program to find the sum of 1 plus 1 by 8 plus 1 by 27 up to 1 by n raised to the power 3, where n is the number input by the user. Now, look at the Python code. In line 1, the user is prompted to input the value of n using the input function, and the input is stored as an integer in the variable n. In line 2, the variable sum is initialized to keep track of the running sum of the series. In line 3, the for loop iterates from 1 to n, inclusive. In each iteration, it calculates the term 1 by I power 3 where I is the current value of the loop variable. In line 5, the calculated term is added to the running sum using the plus equals operator. That is sum equals sum plus term. In line 6, after the loop completes, the program prints the calculated sum using a formatted string. The colon dot for f inside the curly braces is used to format the output to 4 decimal places. When you run the code, now, check the output, the program will prompt you to enter a value n, here it is 5 and it will calculate and display the sum of the series up to 1 by n power 3 terms. So answer is 1.1857. Question 7. Write a program to find the sum of digits of an integer number, input by the user. Now, look at the Python code. Line 1. The user is prompted to input an integer number using the input function, and the input is stored as an integer in the variable number. In line 2, the variable original underscore number is used to store the original input number for reference. In line 3, the variable sum underscore of underscore digits is initialized to keep track of the sum of the digits. In line 5, the while loop continues as long as the number is greater than 0. In line 6, inside the loop, the last digit of the number is obtained using the modulo operator mod. In line 7, this digit is then added to the sum underscore of underscore digits. In line 8, the last digit is removed from the number using integer division, number integer division equals 10. In line 10, after the loop completes, the program prints the calculated sum of the digits using a formatted string. Now, look at the output. When you run this code, the program will prompt you to enter an integer number. Here we have given 68, and it will calculate and display the sum of its digits as 14. Question 8. Write a function that checks whether an input number is a palindrome or not. Note: a number or a string is called palindrome if it appears same when written in reverse order also. For example, 12321 is a palindrome while 123421 is not a palindrome. Now, look at the Python code. Line 2, the user is prompted to input an integer number using the input function. The input is then converted to an integer and stored in the variable number. In line 3, the variable original underscore number is assigned the same value as number. This variable will be used to store the original input number for later comparison. In line 4, the variable reverse underscore number is initialized to 0. This variable will be used to store the reversed version of the input number. In line 5, the while loop is used to reverse the digits of the input number. In line 6, in each iteration, the last digit of the number is obtained using the modulo operator mod. In line 7, the last digit is added to the reverse underscore number after shifting the existing digits to the left by 1 place, essentially reversing the number. In line 7, this is achieved by multiplying the reverse underscore number by 10 and then adding the digit. In line 8, the last digit is removed from the number using integer division. Number integer division equals 10. After the loop completes, the reverse underscore number variable will hold the reversed version of the input number. In line 9, the program checks whether the original input number, original underscore number, is equal to the reversed number, reverse underscore number. In line 10, if they are equal, it means the input number is a palindrome, and the program prints a message indicating that it's a palindrome. In line 11 and 12, if they are not equal, the input number is not a palindrome, and the program prints a message indicating that it's not a palindrome. Now, look at the output. The number 1234321 is a palindrome and the number 123,456 is not a palindrome. Question 9. Subdivision 1. Write a program to print the following patterns. You can see the pattern here. Now look at the Python code. In line 1, this line initializes the variable rows with the value 3. This value determines the number of rows from the top to the middle of the diamond shape. You can adjust this value to change the size of the pattern. In line 3, this loop iterates through the range of values from 1 to rows. In line 4, in each iteration, it calculates the number of spaces before the stars using rows minus I multiplied by empty space, where I is the current iteration value. In line 5, it calculates the number of stars using 2 multiplied by I minus 1 multiplied by asterisk, which calculates the correct number of stars in the row. In line 7, the print of space, star statement combines the calculated space and star strings and prints them to create each row. Now, let's see the lower half. In line 10, this loop iterates through the range of values from rows minus 1 down to 1 in reverse order. The pattern is similar to the upper half, but it decreases the number of stars in each row to create the lower half of the diamond. In line 11 and 12, just like in the upper half loop, it calculates the space and star strings and prints them to create each row. The combination of both loops creates the complete diamond pattern. You can check the output with the pattern having rows 3 on the console. Question 9. Subdivision 2. Write a program to print the following patterns. You can see the pattern here. Now, look at the Python code. Line 1, this line initializes a variable called rows and assigns the value 5 to it. This determines the number of rows in the pattern. In line 3, this sets up a loop that iterates through the range of numbers from 1 to rows plus 1, inclusive. In this specific case, it means the loop will iterate from 1 to 6, since rows is 5. In line 5, this calculates the number of spaces needed before the numbers on each row. It does this by subtracting I, the current row number, from rows and then multiplying the result by a space character. The variable space holds these spaces. In line 6, print of space, and equals empty string prints the spaces without moving to a new line. In line 9 and 10, this loop prints the decreasing sequence of numbers on the left side of each row. It starts from the current row number I and goes down to 1, printing each number without a space in between. In line 13 and 14, this loop prints the increasing sequence of numbers on the right side of each row. It starts from 1 and goes up to the current row number I, printing each number without a space in between. In line 17, this prints a new line character, moving the output to the next line for the next row of the pattern. So, when you put it all together, this code generates the specified pattern with the given number of rows. Each row has leading spaces, decreasing numbers on the left, increasing numbers on the right, and a new line character at the end to move to the next row. You can check the output on the console. Question 9. Subdivision 3. Write a program to print the following patterns. You can see the pattern here. Now, look at the Python code. Line 1, rows equals 5. This initializes the variable rows to 5, which determines the number of rows in the pattern. Line 2, the outer loop for I in range of rows, 0, -1, iterates from rows down to 1, inclusive, in reverse order. This controls the number of rows in the pattern. In line 5, inside the loop, space equals rows minus I times empty string calculates the number of leading spaces needed before printing the numbers on each row. It subtracts I, current row number, from rows and multiplies the result by a space character to create the desired number of spaces. In line 6, print of space, end equals empty string prints the calculated spaces without moving to a new line. In line 9, the nested loop for j in range of 1, I plus 1 iterates from 1 to I plus 1, inclusive, where I represents the current row number. This loop prints the increasing sequence of numbers on each row. In line 12, print empty function, at the end of each iteration of the outer loop adds a new line character, moving the output to the next line for the next row of the pattern. Now, look at the output. This code produces the pattern we described, where each row has leading spaces that gradually increase as we move down the pattern, and the numbers increase from 1 to the row number. Question 9. Subdivision 4. Write a program to print the following patterns. You can see the pattern here. Now, look at the Python code. In line 1, this line initializes the variable rows to 3, which determines the number of rows in the pattern. In line 3 and 5, this loop iterates over each row in the range from 1 to rows plus 1, inclusive. For each row, it calculates the number of leading spaces based on the difference between rows and the current row number I. It then prints those leading spaces without moving to the next line. In line 8, 9, 10, and 11, in this part, the code prints the star and spaces in each row. If I is 1, first row, it simply prints a single star. For other rows, it prints a star followed by spaces. The number of spaces is calculated as 2 times I minus 3. This formula ensures that the spaces in each row decrease as you move down the pattern. In line 13, after printing the spaces and stars, or spaces, this line prints a new line character to move to the next line, starting a new row. The first loop produces the upper half of the pattern. The second loop. In line 15 and 17, this loop iterates over each row in reverse order, from rows minus 1 down to 1. In line 20, 21, 22 and 23, it follows the same logic as the first loop to print the spaces and stars, or spaces, for each row. The second loop produces the lower half of the pattern, completing the desired pattern overall. You can check the output on the console. Question 10. Write a program to find the grade of a student when grades are allocated as given in the table below. You can see the tabular column containing the percentage and grade. Percentage of the marks obtained by the student is input to the program. Now, look at the Python code. In line 1, this line of code prompts the user to input the percentage of marks obtained by the student. The input function takes user input as a string, and float is used to convert it into a floating point number, decimal number, since percentage values can include decimal points. In line 3 to 12, in this section, the code checks the value of percentage against different ranges to determine the corresponding grade for the student. It uses a series of if and elif, else-if statements to decide which grade to assign. The conditions are structured so that they cover different ranges of percentage values. If the percentage is greater than 90, the student gets an A grade. If the percentage is between 80 and 90, inclusive, the student gets a B grade. If the percentage is between 70 and 80, inclusive, the student gets a C grade. If the percentage is between 60 and 70, inclusive, the student gets a D grade. If the percentage is below 60, the student gets an E grade. In line 14, this line prints the determined grade for the student based on the input percentage. It displays the result in the format the grade of the student is, grade. So, when you run the code, it takes the percentage as input, checks it against the given ranges, and then displays the corresponding grade based on the grading table. You can check the output on the console. Thanks for watching. Watch the upcoming videos. Subscribe to my YouTube channel to stay updated with engaging content and never miss out on my latest videos.